Until recently, West Virginia has been a state that many have known about, but few have really seen. The highest state east of the Mississippi, it possesses many attractions scarcely known beyond its borders, including lush forests, magnificent panoramic views, and is a veritable paradise for fishermen and hunters. Once in the heart of West Virginia, it is easy to understand why residents fondly call their state almost heaven, and why visitors often respond, and almost is hard to get to. Until recently, rugged terrain has thwarted all the great efforts to open the heartland of this beautiful state to visitors. In fact, it wasn't until the nation's 200th birthday that a combination of enterprise, ingenuity, courage, and technology began forging the key links to a highway system that would at last open one of America's most beautiful states to all its citizens. This is a story that in fact really began over a half-century ago. American Bridge had been here once before, back in 1911, when it helped erect a short, simple span. A story of the mighty span that leaps over the broad New River Gorge in central West Virginia and is a special chapter in the annals of bridge design and construction. It crosses one of America's most treacherous, if little-known rivers, beginning in North Carolina, winding through Virginia, and terminating 320 miles later in a confluence with the Gauley River to form the Kanawha River. New River is mainly known for its swift currents and violent rapids, which annually attract and challenge hardy navigators on rafts. 1911 was also a big year for the West Virginia road system. Before that, all roads were built by manual labor. Every man between 21 and 50 had to work on the roads 2 days each summer. But at Williamstown in 1911, with a grand budget of $9,500, a 1.5-mile concrete road was built, the humble beginnings of what would become one of this country's most concentrated and modern road networks. By World War II, a short 30 years later, West Virginia had built a total of 15,500 miles of paved road. And by the mid-60s, West Virginia, which ranked only 35th in population and 41st in area, ranked 6th in modern highways, with over 35,000 miles of paved roads. But even the great interstate road network, which had made most other states completely accessible by auto, did little more than skirt West Virginia, still leaving most of its wonders many difficult miles away. It took a special act of Congress to finally make the lovely attractions of West Virginia available to the rest of the Americans. The Appalachian Highway System provided the means of building a number of corridor roads, which bisected the state and presented designers and builders with the most awesome challenges they had ever encountered. Most central of these new arteries was Corridor L, and with it, the greatest challenge of all, the wide and deep New River Gorge. The engineering firm commissioned to prepare the plans for this formidable undertaking was the renowned design firm of Michael Baker Jr. Incorporated, with the supervising engineer being Carl Knudsen, a veteran with many outstanding structures among his credits. Long experience was essential, for many unique problems were to be encountered. Among the first was locating the precise point from which the future bridge should leap across the wide and deep gap. The answer? At approximately the same location as the 1911 bridge, but over 800 feet higher. Another question was what kind of bridge would be most appropriate to make the long stride over so deep a gorge. Several designs were considered, including an excellent continuous truss design, which would have been economical and appropriate under normal site conditions, but was not practical for this deep and remote gorge, as it would have required piers as tall as skyscrapers. Consideration was given to two suspension bridge designs, one featuring an 1,800-foot center span, but estimated costs were prohibitive, and the tall towers would have intruded on the natural beauty of the area. Another interesting design considered was a novel and spectacular jackknife arch truss, a relatively recent development in bridge design, but high costs and high amounts of concrete ruled it out. What finally emerged after long study was a simple, clean, and symmetrical arch bridge which featured a tremendous 1,700-foot arch span, the longest in the world. But there were some unique problems to solve before the bridge could be built. Locating a firm foundation was one of them, since the gorge had been mined out years before. The main arch footers were prudently located below the mine level. But above the mine level, hundreds of deep borings had to be made to locate any mined-out voids. Two were found in critical places, beneath the planned locations for Pier 4 on the south approach and Pier 20 on the north approach. Gravel and grout was used to form a series of conical underground supports at each location, providing footing. The tremendous weight of the record-breaking arch posed still another problem. Normally, in arch designs, the bottom cords of supporting trusses carry the major portion of the compressive stress. However, for this bridge, these cords would have become too massive. Therefore, to create an economical structure, both top and bottom cords share in the compressive supporting stress. Ecology was another major factor. It was essential that the bridge blend in with the beautiful natural surroundings rather than stand out. So the bridge was located entirely within the gorge, and the construction material selected was unpainted USS Corten steel, a high-strength low-alloy steel which is not only stronger than ordinary bridge steels, but which protects itself from atmospheric corrosion. It develops a natural, enduring, earth-colored oxide when boldly exposed to the elements, and grows more handsome with age. Monumental structures were nothing new to American Bridge, which had already built most of the nation's great bridges, including the previous arch record holder, the Bayonne Bridge in New Jersey, completed in 1931. But this one, because of its great size, steep terrain, and remote location, was at least going to be difficult. You don't just build a big bridge, and building this one took as much planning as it did manpower and equipment. Safely spanning such a wide and deep obstacle without